Okay, question number 8 is, I think, by far the most difficult question on the paper. We have a gradient function with an unknown value, and it wants us to find the area under the curve. So we're going to need to get the equation of the curve first by integrating dy by dx, and then we're going to need to integrate that again to get the area. So we've got some curve that looks like, I don't know, doesn't really matter. But ultimately, we're trying to find the area between those two values. But we need the y equals equation to do that. So we're going to need to integrate this. So y is going to be the integral of 2x plus I write ax to the minus 3 plus 3. So that's going to be, add 1 to the power, divide by the new power. That's going to be 2x squared over 2. So that 2's will cancel, and that's just x squared. Here we're going to add 1 to the power, divide by the new power is going to give me ax to the minus 2 divided by minus 2. So that's going to become a negative and divide by 2. And then we're going to have a 3x here. But we'll have a constant term that we don't know the value of yet. We've got a c term. We are told that this goes through 1, 8. So that coordinate there is 1, 8. And we can use that to help us simplify this down a little bit, or help us get a relationship between a and c. So when y is 8, x is 1. So we're going to have 1 squared, which is 1. 1 to the power of minus 2 is 1, so that's just going to be a over 2 plus 3 times 1, which is 3, plus c. So we've got that 8 equals 4 minus a over 2 plus c. Take away the 4 as well. We've got 4 equals c. I'll put the c first because it's positive, minus a over 2. So we've got a link between c and a. So my c value is going to be a over 2 plus 4, or 4 plus a over 2. So we can say, the best thing we can say is that y is equal to x squared minus ax to the minus 2 over 2 plus 3x. And I'm gonna write that c is equal to a over 2 plus 4 here. Some people that I've spoke to kept the c's in, but I think having only one variable in the function makes more sense to me. So that's the equation of the curve. So some quadratic, well, not a quadratic because we've got an x minus 2 term, but that's the equation, and then we're going to need to integrate this between 1 and 3. So the area is going to be the integral between 1 and 3 of x squared minus ax to the minus 2 over 2 plus 3x plus a over 2 plus 4 dx. So I'm going to integrate this. So that's going to be x cubed over 3. Add 1 to the power, divide by the new power. Add 1 to the power is going to become x to the minus 1. Divide by minus 1 is going to give me minus 2 here. So I can put a plus here and cancel out that negative sign there. So minus over minus is going to be a plus. 3x is going to become 3x squared over 2. The constant term is going to become ax over 2 and 4x, because we've got 2 bits of constants. So integrating between 3 and 1. And now we know the answer to the area. The area is 30 square units. So this is equal to 30. That's how we're going to find A. So we've got an equation that we can create and have the value of 30 that equals. So we will be able to find A. We've got one unknown and one equation, so it should be straightforward, but the annoying thing is that A appears twice, which I've not seen before, but it's just the manipulation of the algebra now. So we're going to sub in 3 first. 3 cubed is 27, divided by 3 takes us back to 9. Subbing in 3 here, remember that's x minus 1 is the same as 1 over x. So that's the same as A over 2x. So that's going to be A over 6. 3 here is going to be 27 over 2. 3 here is going to be 3A over 2. And 3 here is going to be 12. We're then going to take away what we get when we sub 1 in. Anytime we see the x, we're going to have a 1, so that's going to be a third. It's going to be A over 2. It's going to be 3 over 2. A over 2 again, and 4. And that needs to equal 30. So let's collect up the constant terms first. We've got 9. I'll do this on my calculator. 9. We've got 27 over 2 and 12, which is 69 over 2. So that was this term, and this term. The A, we've got an A over 6 and a 3A over 2. So 1 over 6 add 3 over 2 is 5 over 3. So we've also got, for the first bracket, 5A over 3. Second bracket, we've got a third, 3 over 2 and 4. Which is 35 over 6. And the A terms, we've got an A over 2 and an A over 2, so that's a whole A. So it's already looking a bit better. So now we can collect together the 69 over 2, take away 35 over 6. 69 over 2, take away 35 over 6 is 86 over 3. And we've got 5A over 3, take away a whole A over A. So that's going to be 2A over 3. Last couple of steps. I like getting rid of fractions if possible, so I'm going to just times both sides by 3. So we're going to have 86 plus 2A is equal to 90. Take away the 86 gives us that 2A is equal to 4, and then therefore that tells us that A divided by the 2 tells us that A is as I said, really difficult question. It's all about keeping a cool head, one step, trying to find your C value in terms of A, because that's the best we can do, and then integrating that again with our A's in and working through it to get the value of A. As I said, trickiest question on the paper by far. Big 9 mark question.